Hi, welcome back to track 2. We've got Sam Thomas here to speak about PHP unserialization vulnerabilities. I'm getting the impression that quite a lot of you in the audience already know Sam. I think this is the pen test road. It promises to be quite a good talk with some demos, so that'll be fun. Let's wait and see how you go, no pressure. So I'll just hand over. Any questions as we go along, or
yeah, probably better at the end, just in case.
Questions at the end.
I'm going to address it.
Cool. So we'll kick off. Thanks very much.
Right. So good morning, everyone. Those who I know, and you. Does it mind?
Oh, I see what's happening now. It's all right, I'm fine.
I might turn the volume down.
There we go. There you go. So it's on mine set in DB now. Want to say something?
Hello.
Yeah.
Everyone hear me? Can the one person at the back hear me?
That's a long way away. There you go. Cool.
You've got the best view.
Flip it on the outside.
Okay, so good morning to everyone I know and everyone I don't know. My name's Sam Thomas. I'm the head of research at Pentest, and the talk I'll be giving is called PHP Serialization Vulnerabilities. What are we missing? The obligatory who am I slide. The boring stuff's in the bio. Basically, I'm a big kid who likes playing with stuff. So what is PHP unserialization vulnerability? So basically, over the last few years, we've seen this slowly emerging class of vulnerabilities called object injection. It does appear in other languages, etc., but really I'm going to be focused on PHP and focused on unserialization. Just recently, and I didn't know about this till I came to prepare the talk, but someone whose name I don't know, but it's on this leapfree.nl blog, sort of demonstrated a different way of exploiting a similar vulnerability. Now, I first came across this on sort of a normal pen test, just had a few days to test an app, did a bit of recon. It was forked from an old version of SilverStripe, which is an open source CMS, so did the normal thing, had a look through the change log, and this entry sort of jumped out at me. So after getting past those first 3 words, which is remote code execution, I sort of had a bigger look at what it said. Obviously, we ignore potential. That just means there's not a public exploit normally. And but this word serialization, I didn't really know what it meant, so I went off to try and find out. And that's when I came across this amazing research by Stefan Esther, who basically found the issue. I think it's quite important to make sure he gets due credit, because when we talk about classes of vulnerabilities like SQL injection or cross-site scripting, we don't attribute those to a single person. They're like so obvious that loads of people would have found them almost immediately that those things existed. But this function unserialized was around for a long time, and no one really realised it could be vulnerable. Now, I'm guessing a lot of other people had similar experiences, because sort of around the same time, a lot of people started talking about this class of vulnerabilities and some examples of the stuff, the exploits that you could do with it. Now, I wasn't aware of all of this research when I came to prepare this talk, so it scared the out of me. I'm going to talk a little bit about some of the other stuff they've done. So this guy, Arseny Roitov, I hadn't heard of his work, but he did some amazing stuff, basically using built-in classes in PHP as well as the user-defined ones. Egidio Romano has basically sort of really taken on this vulnerability, found a lot of instances of it, set up an OWASP page and done a lot of work there. Okay, so moving on. Basically, sort of, because I learn things more by doing them than by just reading about them, I wanted to sort of talk through 3 vulnerabilities that I worked on exploits for. Now, I was basically trying to be clever here and talk about nice old vulnerabilities talk about the methodology and say you could apply this to more recent stuff. So I went off to have a look at some more recent CVEs, and one jumped out at me. So basically one of the exploits I'm going to show you here today with some small changes would affect this WordPress plugin, which apparently is 30% of all e-commerce sites on the internet. So hopefully I don't have to do as much as I thought I would to justify that this is very relevant now. Okay, I'm not really going to talk about the vulnerability. I don't know if you caught my colleague Paul's talk about static analysis, but we really know how to find this kind of vulnerability. So if you think about SQL injection or cross-site scripting, it's basically user-controlled data getting to a function that it shouldn't do. I'm not going to talk about how we fix it, because basically it's fairly trivial. Just don't unserialize user-controlled data. More recently, with PHP 7, they've introduced a second argument to the function, so you can limit what classes you can unserialize and limit the impact. What I do really want to talk about is the actual technique we use to exploit it. So this is sort of a duplicate of one of the slides from Stefan Esther's original presentation, and basically he introduced this concept called property-orientated programming, and that's part of a much broader area of sort of code reuse exploits, and return-orientated programming is the best known example of that. Okay, so this is the basic agenda of what we're going to talk about. Before we can get to the cool stuff of actually exploiting it, we need some background information. So what is unserialization? Why is it exploitable? And then let's go ahead and exploit it. Okay, so basically there's two functions within PHP, serialized and unserialized, that do the opposite of each other. So serialized generates a storable representation of a value. Got some simple examples there like integers and strings, and it's basically so you can store them in a database or in a local file or something like that. Now the problem comes when those kind of values are exposed to the end user. So for instance, it's passed through a cookie or a get parameter. Unserialized does the opposite and converts this binary string back into the actual value. Now, okay, that doesn't sound all that interesting, but once we get down to actually what things are a value within PHP, it gets a bit more interesting. So you've got 8 primitive types. I think the scalar ones should be well understood. Compound I'm going to go into in a second. And the special types are resource, which is like an open database or an open file handle. These are the one thing that can't be serialized, and hopefully you all know what none. So okay, an array basically consists of a set of indexes and a set of values. In PHP, those indexes could take any value, which could get a bit complicated when you think about, say having an object as an index. But everything we're going to look at will just be integers or strings for the index. Okay, now an object is an instance of a class. So you've got the code behind a class, which defines the properties and various methods. And we can represent that, and in terms of what's serialized, it's just the properties and the class name is, an instance of that object in its current state is represented sort of by that. Okay, so that's a rough idea of what serialization and unserialization is, but why is it exploitable? Basically, that comes down to these things called magic methods within PHP. Now, there's quite a lot of them. I'm not going to go into all of them. But if I sort of explain these 4 briefly, hopefully that will give you a rough idea of the sort of thing they do. So the first one we're going to look at is wake up, and this is the one method actually I'm not going to use in any of the exploits, but it's the one that should start to make us think there might be a vulnerability there. So whenever we unserialize an object, if the class that object has a wake up method defined, that's run, so we're starting a process of code execution. Typically, it's basically meant to reinitialize those resources that I mentioned couldn't be serialized. So for instance, if you serialize something that's supposed to be connected to a database, that connection will be broken when you serialize it, and when you unserialize it, it will try and bring that connection back up. And the next one is destruct, which is basically called by the garbage collector. So when an object is destroyed, this destruct method is invoked on the object. Typically it cleans up references, One interesting thing it might do is finish any unfinished business. So say we had an object that represents like a file stream with a buffer, has a buffer as a property. There might be data in that buffer, and while it's destroying it, it might say, oh, I want to clear out the buffer and write that to my file. So you can imagine if we could give it an arbitrary object with data in the buffer and a path of our choice, suddenly we're doing interesting stuff. Okay, the next one is ToString, which basically happens when we treat an object as though it were a string. So the simple example I've given there, if you try and echo out an object, it will invoke this method to convert it to a string and display that. And this can get interesting if there's complex rendering methods. So say we've got an object that represents a page, that might reference a template or something like that, and if we can control where it's looking for that template, then we're doing something interesting. The final one we're going to look at, which might not be obvious why it's relevant now, but hopefully will become clear soon, is this call method, which is invoked if we try and call an undefined method on an object. So we call a method called foobar on that object, but it doesn't have that method defined. If it does have a call method, it will try and sort of catch that with the first argument as foobar and the second argument as the arguments that would have been passed to the function. So that's essentially why we can start to see it might be exploitable. We can start a sequence of code running. But the other stuff I wanted to talk about is what makes it particularly exploitable in PHP. So a lot of complex applications basically define something called an autoloader. So whenever you try to access a class that it doesn't know about, it's going to go off and try and load that class file. That's basically how you define it, but essentially it means you could have a lot of different classes available to you for your exploit. The next thing, I didn't actually know what this was called, I had to look it up, and that's kind of a dry technical explanation from the manual. But what this means is that any variable, or indeed any property of an object, could take any value. So it could be an object, an array, all the different things we looked at. Then finally, people don't really seem to mention this one, but I certainly needed to find out about it, and it's really important, is all functions within PHP have a variable number of arguments. So you might define a function to take 2 arguments, but if someone invokes it with no arguments, it's just going to pass null as the 2 arguments. So combining these 2 things, we start to see we could put completely unexpected objects as a property. So say we're going to invoke a commonly named method like close or something. Might be trying to close a file, and we could put something completely different there and start that code. Okay, so I think we're ready to start looking at the exploits. And the first one, this is the basic methodology we're going to follow. So this is pretty much what Stefan Esther said in his papers. That we start off by finding somewhere where we control the data that's unserialized. Then we work out what classes are accessible to us. We try and find a magic method to kick off the set of code we're going to run. And then we basically try and find a way of getting from that point to something interesting. Now, when he sort of ran through these, it was very much like step 1, then we go to the next step, we go to the next step, we go to the next step. So the first vulnerability we're going to look at, I mentioned right at the start. I was just on a test, looked at the change log, it sent me to this paper. I sort of had understood some of that basic stuff I've gone through there and thought, right, I'm ready to exploit it. So find an entry point. From the change log, it was fairly obvious where it was doing something wrong. It's unserializing a cookie. Okay, so what classes can we use within our exploit? SilverStripe does have an autoloader defined. I'm not going to go into all the details, but basically it uses a manifest-based system. So there's a separate PHP executable that constructs a big list of all the classes within the code base and what file they're in. And then when we go to try and access a class that it doesn't know about, it just checks this list and knows up the class. So that's pretty good for us. Basically means we can get to nearly every class in the code base. Okay, so then we need to find starting points. Now, I mentioned ToString earlier, but I'm going to ignore it for now because it wasn't clear to me at first that we should be looking there. So we're going to look at struct and wake up. looking through the code base, the available classes, there's basically no wake-up methods and 5 destruct methods. I'm not going to go through each of them, but I thought I'd go through a couple of the ones that we reject, sort of to show you how easily we reject them. They don't do anything useful. So the first one is MySQL query. Basically that's taking a property of our object, checking if it's a resource, which it couldn't possibly be because we can't serialize a resource, and then doing something boring anyway. The second one, CSV parser, we look at the destruct method. That could be interesting because it's calling a function called close file. But we go and look at that, and it doesn't actually really do anything. You know, it'll close a file if there's an open handle and set a bunch of properties to boring values. Now, the one we actually do use, sort of jumping past a few more, is this one, which is in a class called sendlove. Now, this takes the property writers, which is essentially an array of writers, and iterates through each one and invokes a function called shutdown. Now, it's probably important to say that the exploits that Stefan Esther used, a lot of the ones he demonstrated started with this very same class and very same function. So that's what we've chosen sendlove to start with. Okay, so where can we get to from there? Like I mentioned, his approach, not his approach, but sort of simplifying it was very much where can we get to in the next step. So there's 5 shutdown functions, and these are the exact same 5 that he went through in his example. And he basically said they're all useless except sendlove writer mail. Now immediately that we've got that, basically we can send arbitrary emails, which is interesting but not really where we want to get to. So he then showed that basically this would invoke a method called render on one of its properties, and he had 7 classes with render methods, rejected 6 of them, one of them did something interesting, bang, we're running code. SilverStripe, there was only one object with a render method, and it didn't do anything interesting. So, you know, it seemed like a dead end, basically. So I went back, went through all those destructs, all these methods, basically stayed up late into the night thinking, that changelog said I could have code execution, you know, where is it? I can send a stupid email, but that's not what I'm after. So that was pretty much what I looked like when I went to bed that night. You know, I had a good night's sleep, sort of fresh perspective in the morning, stepped back and reread these papers and tried to understand if I'd missed anything. And what I'd basically missed is that we shouldn't only look at, you know, what we're invoking directly, but if we trigger any of those magic methods. So we don't only need to look at the objects with a shutdown method, we need to look at any objects with a call method, which we could invoke by telling it to shut down. Again, I'm not going to step through all of them. There's one I want to show you quickly because I'm going to talk about it later. Now, this is basically a really common pattern. I know this is going to be a bit sort of circumstantial, but we're going to see it again and I'm going to say it's common. So this proxies the method that's been invoked onto another object. So in this case, the form property, this function with the same name is called with the same arguments. I saw this a ton of times and didn't think it could ever be useful, because why wouldn't we just place the object that we wanted to call the method in rather than proxy through it? But we'll get to that in a minute. So this is the one we're actually going to use. Now what this does is it takes the method name, converts it to uppercase, and then it searches one of its properties to see if it's supposed to handle that method. So actually that method could have any name, as long as we set up this priorities property to cover that method, it's going to catch it, and then it goes ahead and logs something. Now, in terms of interesting stuff we could do, you know, logging something to presumably a file sounds pretty interesting. So sort of as I mentioned, this is really, really useful because of what triggers it. So any method on any property of an object could trigger this. And so basically once we know we've got one of these, we're looking through those destructs or wake up for basically anything that invokes a method on one of its properties. So looking a bit further into what it actually does, it calls the log method, and from there basically this constructs an array with the details of the event that it's logging. Now what's handy for us is it takes stuff like the parameters that are passed to it, it calculates a timestamp, but it merges those with one of the properties, so actually we could overwrite anything that was passed to the function by setting this extras property, it then goes ahead and invokes the write method on this object. Now, I don't want to sort of jump through loads and loads of code, so we go straight to basically, this is the exploit that we built. So the initial object that we supply is one of these Zen logs with a single writer. So when this is destroyed, it's going to invoke that shutdown method. Now, we've set this priorities property to basically say, yes, catch shutdown. We've set the message for what to put within the log entry. And, I haven't spoken about this class, but it's exactly intended to log stuff to a file. So basically, we're just telling it to write that message to a file. So we go ahead and try that on the local machine. And great, we're writing text to a file. And, we think we're just moments away, basically, from getting shell execution. So I went ahead and changed that to some PHP code to execute whatever we wanted. And I got 403. So it turns out that basically they were using htaccess files to prevent PHP execution. Now, at this point, I spent way too much time on the test, probably had reports overdue, etc. And I've never actually completed this exploit. I was hoping to do it for this talk, but the time suddenly got up with me. So this is going to be a bit hand-wavy, but there is a way to do it. Basically, PHP has this mechanism called filters that you can use for files, and you can, for instance, set up a base64 decoding filter. Now, PHP is nice and ignores any characters that it wouldn't know how to base64 decode. So what we do, we basically take this and repeatedly decode it, and eventually it swallows up all the characters that we don't control as they turn into invalid characters. And where we've got the text that we do control there, we put a repeatedly encoded value, and eventually we can write an arbitrary file to an arbitrary location and write a new htaccess file that will re-enable PHP execution. So I'm afraid that's where the first one finishes, but the next two are hopefully much more interesting. I just wanted to go through that one because it's the first time I came across the issue. So this is, I think, to be honest, it's my favourite web application vulnerability. I guess that sounds a bit weird, but hopefully this isn't a strange place to say that. So I'm not going to be able to go into the full details of the vulnerability because it's quite complicated, but we'll have a quick look at it. So finding an entry point is basically a security issue with MySQL that they haven't recognised as a security issue. If you set up a table to use the UTF-8 character set, it doesn't handle 4-byte characters properly. And it's quite similar to like a null byte poisoning attack that we see in various places. So if we try and set a value to foo and then one of these characters bar, it turns into just foo. Now it wouldn't occur to me, it would occur to me that might be relevant to some issues, but certainly not this one. So this guy, Tom Van Goth, basically had an amazing insight into some of the internals of Wordpress and figured out that we could abuse this to trigger unserialization, and I'll show you a little bit more of that in the demo. Okay, so the next step is to look at what classes are accessible if there's an autoloader, if we can get to them. In WordPress there's no autoloader, so we're extremely limited in what classes we could use. So the next thing is to go through these starting points. Now, this is where we have to use ToString in this example, so sort of to make the point that we should be checking that method as well. If you think about the sort of data that's going to be unserialized, it's almost guaranteed to treat something as a string. Okay, so we've basically only got 3 methods that we could possibly use. There's 2 destructs, and they're both about as boring as you could get. And then there's this one complex ToString method. Now, this is when I was talking about, going next steps. Here we can take a bit of a different approach. So we're basically faced with this complex set of possible places we could go. And checking through all of those is going to take an age. But what if we identify where we want to get to? We identify some useful piece of code that we could target, then suddenly it's quite an easy problem to solve. And similar to some of those static analysis problems Paul was talking about. So okay, can we find something useful? So ignore the actual code and looking at the comment, is there anything that sort of stands out to anyone as potentially a bit more dynamic or interesting than just displaying the name of the thing? Yeah, go ahead.
The fact that it says it's translated
Exactly.
suggests that it's going through
Mm. Well, it's certainly going to be more dynamic than just displaying a fixed value. So I didn't get there straight away, but it shouldn't be surprising that I ended up looking at a class called translations, and that has a very interesting function because it's for dynamically creating a function to deal with pluralization. And this create function is quite similar to a val. So basically, if we can feed code into there, it will be executed. So basically, we start from that endpoint and work our way back to the ToString method from WP theme. So going back, we see that the values that are fed to this are read from a file. We go back and see we can control that file. Looking at what it could be, it couldn't be like a HTTP URL, because it invokes, I think, a function called isReadable, which won't accept a HTTP URL, but it will accept an FTP URL. So we could host this language file externally and just point to it. And then going further back, we need to have an actual name for it to try and translate, and we need to tell it that that name is with a text domain that it doesn't recognize. So this is the exploit. It's quite simple, really. We've got the WP theme object, and it's got three properties. One is headers, which is an array, and it has two entries, name and text domain. As I mentioned, it has to have a name, and it has to have a text domain it doesn't recognize. And then we just set the theme root to an FTP directory. We have to have a style sheet, which we'll see, and that's basically it. So I kind of mentioned earlier that the issue was all about 4-byte Unicode characters. Now I'm sure you all know full Unicode character set, and I'm fully aware that there's one character on the table that we use. But just in case you don't, obviously that's the one we're going to go for. Okay, so now pray to the demigods, and we'll see if this works. That's basically the source code for the exploit we'll be using. So basically we're building a version of this object with the properties set, how I showed. We're going to URL encode it and serialize that. Now, as I mentioned, that's sort of grabbing something from the FTP site. So let's have a quick look. What's on there? So you saw we set the style sheet parameter y to y, that's used in the folder name, and then it's going ahead looking for the languages, and we've set up a US language in there. So this is a binary file format, it's not that readable. I think it should be fairly obvious where we've injected something. So it's basically this plural function. We've given it a bit of a malformed value to include our code. So let's go ahead and load up Wordpress. Now this issue is only exposed to authenticated users, so you'd have to either have registration available or some wiki account that we could get into. So we can update various properties of our user profile. So I've set my username to foobar. Now, if I quickly grab a pile of poo, we can put foobar. terminated it at the pilot put. Now, what Tom Van Goghen basically noticed is that there's quite a complex process going on here. If we try and give a value that looks like serialized data, it's going to serialize it again and then unserialize it later. But if we give a value that doesn't look like serialized data, it's going to put it in. When it gets it out, it's going to check if it looks serialized and unserialize it. And basically, we can use this to our advantage. So if I put something like a serialized integer in there, it should. It just comes out as 1 because it's getting unserialized. And I guess to demonstrate a bit more clearly, if we put a serialized array in there, so that's just an array with 0 elements essentially, it should. So not only is it unserializing it, it's invoking ToString on it, and that's what the ToString method of array will do. Okay, so if we step back to foobar. Okay, so this is the request. Now there's a slight complication here that the username field, that sort of field we looked at, won't accept any null bytes, which we are going to need for our exploit, but fortunately there's a couple of fields that do accept them. So what I need is just the terminating part of that function, and I'm going to put it in the aim parameter. Basically run that code which generates the serialized value. It's all URL encoded and a bit ugly looking. I guess let's just drop it to the decoder quickly. Sort of see vaguely that it's the object we were talking about. So we're going to go ahead and basically set our aim, the value of our aim field. Get rid of the 3. Put in all that. So that's updating, okay. And now it's literally as simple as and we can run various commands. Okay, so moving on to the next one. This is an issue in Joomla, found by Egidio Romano, who I mentioned before. Now, when I came to prepare this presentation, I wasn't aware of the work that Johan Darsa had done. So he's been working on RIPS, a PHP static analysis tool, but there's a version which isn't public yet, which he's been working on, that both finds these vulnerabilities and tries to find the potential exploits, chains of objects that would cause things to happen. Now, this really surprised me, basically. I've got this code execution vulnerabilities that I was going to show you guys, I thought was quite good, and it turns out he found a really simple one. Now, the reason I didn't know about it is because it uses a sync I've never heard of. Basically, there's a function in PHP, method exists, to check if a method exists. And until recently, if you fed a malformed class name through to that, you could basically, in some situations, abuse that to cause a local file include. Now, like I said, I didn't know about this before, so it's a bit difficult for me to be neutral, but I think mine's better primarily because it doesn't depend on this. So, you know, we're looking at an old vulnerability from like 2013, but that's still 3 years since null byte poisoning was fixed. You know, this second one, I don't think we can really call them out on using a PHP vulnerability that comes after the actual thing. So let's step through this methodology again. So you kind of, you know the drill there, unserializing something they shouldn't be, looking at what classes are loaded. It's a bit complicated how the autoloader works, but essentially it's if the class name begins with a certain prefix, with J in this case, we split on every capital letter. So I've just given an example there, like there's a class called JCacheController. It goes and looks at libraries, Joomla, cache control. So we can get to loads and loads of classes. We need to find a starting point. There's basically only one useful one, and this is used by all the other exploits that I mentioned. That there's a system plugin for debugging that invokes certain things when it's destructed. So to actually get to any useful code, we have to have this debuglang parameter set as true, and that's going to invoke this function, and that's going to invoke get on one of its properties. Now, as you can imagine, get is quite a common function there. So when we actually look at it, there's a whole load of gets. And sort of looking at these class names, it shouldn't be surprising that all those JCache ones, there's a bunch of JGitHub ones, there's a lot of classes or objects that are calling get on each other. It's sort of quite intertwined. So stepping through these, one of the first ones that grabs our attention is not because it's going to be useful to us straight away, but because it's a potential endpoint, and quite an exciting one as well. So this class is basically for invoking callbacks or cached callbacks. You know, it takes the parameters and it ends up calling this function call user funcarray. Now, as an endpoint, this is quite trivial to abuse if we control both arguments passed to it. We could just give it a function name and an argument, and we're running code. It's nearly trivial if we control just the first argument. So we could give it an arbitrary object and an arbitrary method name, and alright, we don't control the arguments, but that'll give us a good place to look for you know, any method on any object. Hopefully we can find something useful. So at this point we're starting to think, can I get control of that first argument? And I thought it'd be a lot easier to find something, but this was actually the closest I could come to complete control. So we've got GitHub GIS, which is essentially generating a path and then using a HTTP client to get a response from that path, and it constructs the URL. Now, basically, this also calls a bunch of gets on another one of its properties to get the values for these properties, API URL and API username. Now, another thing we come across is like a simple get method that we can basically completely control what it's going to respond with. So, given any property, we can basically set up this array to give any value back. Cutting a long story short, if we give it a malformed URL, that basically throws out the URL generation, and then we give it a username. When it's trying to construct that URL, it will stick the username at the front with an @ sign, and there's nothing else there because we've basically broken it with the malformed URL. Okay, so we've not got complete control over that, but we can now invoke get on any object with a string that we control almost all of. So if we go back to that cache controller callback, it mentioned that you could also access it with a string shorthand. Now there's kind of two paths. One's for invoking static methods, which is going to be pretty much useless to us because that's invoked on a class rather than an object. And we don't control any aspect of that class. The other one looks a bit more interesting, particularly because of this comment, which I haven't added in, is in the code, and whenever we see that kind of thing, we think, I should probably look a bit closer. Now, to understand what this is doing, you have to basically notice these double dollars, which is something I certainly wasn't familiar with, and until I came across this. So those are variable variables. In PHP, we can use a variable as a reference to another variable. So we can put the name of a variable in a variable and then access that. So in the example, we've set $A to B, $B to C. If we access $A, it's the same as accessing the variable with the name of the value of $A to $B and C. Okay, so now hopefully we can start to understand what this does. From controlling that string, we can basically completely control the two values given to these two. And it's going to then try and access a global variable with the name that we've given it. So the intention of this is to invoke methods on global objects within the application. It's not immediately obvious why this might be useful to us, because we'd have the same problems as static methods. But if we look a bit further through the code, hopefully we can start to see what we might do. So this I basically hadn't noticed until I got to this point. But if we want to get to the call user function array, we need to have our data set as false, which is what we need the cache to miss basically when it's seeing if it's got a cached value for this function invocation. And that we would think is fine because we've got that get method that we can return whatever we want with. But actually, if we return false, it's going to try and lock the cache. Now that JLanguage is the class we looked at that we could return arbitrary data with, and that doesn't have a lock method. So if we try and lock that, the application's going to error out and it's game over. So that's finally when that proxy method I was talking about comes in. It turns out the call user function doesn't error if we try and invoke a non-existing method. So basically we can pass through that invocation of lock and just proxy through to another object. And here's a class that has the exact same structure as the one I showed before. It's just proxying the call onto its cache. Now the problem here is that this class already has a get method, so we can't actually proxy the get method, but this one's almost a proxy because basically it invokes get on its cache and then unserializes the value. So okay, we have to serialize whatever data we want this to return. So we're past the lock. What does the rest of the function do? There's two paths, one to retrieve a cached result and one to actually invoke the function. So looking at this as just going through it once, it doesn't look that useful. But if you think about we could globalize any variable. So if we globalize result before it's used and then retrieve something from the cache, this result variable is going to stick around. So basically we can pass through that whole sequence of code twice. Once globalizing result, retrieving a value from the cache, and the second time missing the cache and using result as the object we're invoking a method on. So we can finally, hopefully, invoke an arbitrary method on an arbitrary object. And we go ahead and find one that uses a val, and basically we can get code execution. Yeah, so I wanted to mention actually this class JUpdate, we can't auto-load normally. It's not in the directory structure where we'd expect it to be. We'd actually expect it to be called JUpdate or update. So what we can do is simply create a dummy class that tries to load JUpdate or update, fails, but then it knows about JUpdate. And there's other methods of indirect inclusion. So for instance, if we find really useful methods in some class that we can't auto-load, it could be worth looking if other classes that we can auto-load include that class. And after doing all that, I got a 500. So it turns out that there was a reason we can't run through that whole process twice. Right at the start, the first thing we're invoking the get on is basically checking the response code from this client. Now all we actually need to do is give our object a code property and set it to 200, and we bypass that code. So here is the exploit. Now, if you remember, we had to set debug name to true to actually invoke the destructor. Then that's going to go ahead and try and invoke get on JGitHub GIS. That's going to try and work out its URL. but this bit in the argument is calling get on its client. We pass through all that stuff. Basically, that's going to be a hit in the cache the first time through. It's going to grab. Nice job. Who's taking pictures of my yeah, it's going to grab that object, set the global result variable to that object. It's going to pass through everything back again, miss the cache, and basically invoke this method on the object that we've put in result. So the demo god's winning. Let's see if we can do that. Hopefully, probably shouldn't say this, but this one should be a lot simpler than the last one. What's that? Ah, I've got intercept on, thank you. Right, so it's loading up Jim now. This is the big long set of code that we use to create the object that we're going to unserialize. Literally all we need to do is set a highlight parameter to a very long value and pop it runs our code. I know that kind of looks almost too simple, so let's go ahead and change the code quickly. I'll just try once more and then I give up. No idea why that's not working. I don't think it's worth sort of showing you a video of everything else we've done. That's basically that exploit. So that's really me done. If there's anything I'd want you to take away from this talk, if there's any developers in the audience, really think seriously before you use any kind of serialization or unserialization function. if there's any testers or researchers, I think it's an easy issue to find, maybe not so easy to exploit, but do it is fun. You know, that's the methodology. I think we're running a bit short on time, so I won't go through that again. Has anyone got any questions? Okay.
So say you've got a WordPress plugin,
Yeah.
and all that plugin does is unserialized get C. Was it get declared classes will show you what you can call from that?
Yeah, so basically if we're looking at you know, a vulnerability and we don't have an autoloader, what I'd normally do is chuck, you know, var dump or echo get declared classes just into the source code just before we unserialize and look at what's loaded. There are some other examples than these that I looked at where people might say, you know, want to force a certain class to load. So I know I looked at one recently where they wanted some kind of email classes. So they set various other parameters so that classes were loaded before the unserialization was triggered. But yeah, I think, you know, if you dump the declared classes just before you unserialize, then you should see everything that's accessible to you without an autoloader. No one else?
Any other questions?